Hi everyone, in this video I will teach you how to create quadratic equation given the roots. I know two ways on how to do this, so I will teach you the first one. Let's go straight to the examples. I have a lot here, I have 10, so please bear with me. So the first thing we will do is to create two binomials out of the given roots. So since we have x equals 5 and x equals -4, um, we will first create two binomials out of these two. So x equals 5 is x minus 5 as our binomial. So you just need to consider the opposite of 5. And since we have x equals -4, that means it's x plus 4, right? X plus 4. So now that we have these two binomials, we just need to multiply this using the FOIL method. So x times x, that gives us x squared. X times 4, that gives us 4x. -5 times x, that gives us -5x. And -5 times 4, that gives us -20. And finally, we can combine the two terms in the middle. That gives us x squared minus x minus 20. Okay, so that's how we answer the first one. Let's have another example. This time we have a fraction. So let's begin with x equals 4 and x equals -2/3. So with x equals 4, the equivalent binomial of that is obviously the opposite of 4, which is negative, right? So it would be x minus 4. Now with a fraction, the first thing we will do here is to put this 3 beside x. So that x or that 3 becomes the numerical coefficient of our x. So this will be 3x, and the opposite of -2 is +2. Okay, and then let's multiply this again using the FOIL method again. So x times 3x is equal to 3x squared, right? And then x times +2 is equal to +2x. And then -4 times 3x is -12x. And -4 times +2 is equal to -8. And then we can combine the two terms in the middle, of course. So 2 minus 12 is -10x minus 8. So this will be our quadratic equation. Okay, let's go to the next example. So here we have, since we use C here, that we have a positive negative square root of 11, which means I will separate that into two. The first is x equals +11, and the next is x equals -11. So to convert this into binomials, we will have the opposite of that, which is -11, negative square root of 11 rather. Opposite of negative square root of 11 is x plus square root of 11. So here, we will not be doing FOIL method. All we need to do is to multiply the first terms and the last terms. The reason behind that is, as you can see, they are almost identical. The difference are the signs only of that square root of square root of 11. So just multiply the first terms and the last terms. X times x, that gives us x squared. Negative times positive is also obviously positive, and square root of 11 times square root of 11 is obviously 11. Of course, some of you might be thinking, okay, 11 times 11 is 121, right? But the square root of 121 is 11. So, you can just cross out the radical sign, and that gives you 11. Okay, let's see the next one. So here we have positive -3 square root of 2. So we have x equals +3 square root of 2, and we have x equals -3 square root of 2. So convert this into binomials. That's positive, so opposite of that is negative. 3 square root of 2, and then here would be x plus 3 square root of 2. Now, this is almost similar to the previous example because we will not be using FOIL method here. We will just multiply the first terms. That gives us x squared. And of course, the last terms. So 3 times 3 is equal to 9. And then square root of 2 times square root of 2 is 4, yes. And the square root of 4 is equal to positive 2. And that gives us that 2 there. And of course, we need to multiply that 9 and 2. That gives us negative 18. And that is the quadratic equation of those two roots. Okay, let's go to the next one. Okay, so here, oh, what happened? There you go. We have x equals negative 4, okay, plus 2 square root of 10, right? And then the next one is x equals negative 4 minus 2 square root of 10. So here, what you will see is like a binomial within a binomial. Okay, so let's see what do I mean by that. Convert this into binomial. So this will be x, opposite of negative 4 is positive 4. And then I'm going to close that uh, into a parenthesis, the x plus 4. Now this will be outside. Opposite of positive, it will be negative 2 square root of 10. And I'm going to use brackets here. Okay. So here, this will be x plus 4. And then I will enclose that into a parenthesis. Opposite of negative 2 will be positive 2 square root of 10. Okay. So here, I know some of you already noticed this. It's like we are multiplying the sum and difference of two binomials, right? So here, see that they are the same. And also, let's see, here, they are the same. So essentially, we will be just multiplying the first terms and the last terms here, similar to what we did a while ago. So we will consider the entire x plus 4 as our first term. Okay, so which means this will be x plus 4 times x plus 4 minus, okay, so that's this, and then this one. So 2 times 2 is equal to 4, and square root of 10 times square root of 10 is 10, obviously. Okay, so here we can use full method. So x squared, that's 4x, that's 4x, this is 16, right, minus 40, okay, equals x squared plus 8x minus 24. And that is our quadratic equation. Okay, let's go to the next one. Let's see what we have here. Okay, so let's have x equals 3 plus square root of 5 over 2, and x equals 3 minus square root of 5 all over 2. So first step, we need to move this to x, and that 2 becomes the numerical coefficient of our x. So that would be 2x. Now the reason behind that, for some of you might be thinking, why are we doing that? That's actually multiplication property of equality, okay? So 2x equals 3 plus square root of 5, and then this is 2x equals 3 minus the square root of 5. Okay, so this will be 2x minus 3, opposite of 3, okay, and then opposite of positive square root of 5 is negative square root of 5. Okay, so here the ones on the left side, on the right side rather, is just the same as this one. The only difference is this negative sign that will be plus here. So this is 2x minus 3 plus square root of 5. Okay, and again, we will only multiply here the first terms. Those are the first. We will consider 2x minus 3 as our first term, and then this as our last term. Okay, so this will be equal to 2x minus 3 times 2x minus 3 minus 5, right? Square root of 5 times square root of 5 is 5. And then equals, use the full method now, 4x squared, this is negative 6x minus 6x plus 9 minus 5 equals 4x squared minus 12x, they have the same sign, so you will add them, plus 4. 9 minus 5 is 4. So this will be our answer. Okay, let's go to the next example. Okay, so here we have positive negative square root of negative 7. Let's see. So we have x equals positive square root of negative 7. Then we have x equals negative square root of negative 7. Okay. Again, we will convert this into binomial. So just switch the sign of that. This will be negative square root of negative 7 times x plus square root of negative 7. And then again, here we will not use full method. We will just use we will just multiply the first and the last term. So that gives us x squared minus negative 7. So just cross out the radical sign, and that gives you whatever the number inside. Okay. So this is equals x squared plus 7. Okay. We are down to the last three examples. Let's have this one. So here, as you can see, we have an I. So just a reminder, we know that I is equal to the square root of negative 1, right? So if that is square root of negative 1, okay, that is square root of negative 1. And if we multiply that to, oh, what happened? And if we multiply that to this, that becomes square root of negative 3, right? So we can rewrite this as negative 2 plus and minus 5 times the square root of negative 3. Okay, so let's separate the two roots. The first is negative 2 plus 5 square root of negative 3. The second is x equals negative 2 minus 5 square root of negative 3. Okay, and then convert this into binomials. The first is we have x plus 2, opposite of negative 2. And then that will be negative 5 square root of negative 3. This is our first binomial. I know binomial within a binomial, right? This will be x plus 2 again, but this time this will be plus 5 square root of negative 3. Okay, equals. Again, multiply that. That gives us x plus 2 times x plus 2. And then minus this, that's 25 times negative 3, right? And this is equal to x squared plus 2x plus 2x. That one is 4 plus 75. Now that's plus 75 because we will consider 25 here as negative. I know it's minus 25, but we will consider that as negative. So negative 25 times negative 3 is positive 75. And this gives us x squared plus 4x plus 79. There you go. Let's go to the second to the last example. Again, we have here an I. So we all know that I is equal to the square root of negative 1, right? So I is equal to the square root of negative 1. So which means here this is 8 equals, okay, x equals 8 square root of negative 1 equals, and then the other root is x equals negative 8 square root of negative 1. Okay, then convert this into binomials. This gives us x minus 8 square root of negative 1. That's the first one. and then the other one is x plus opposite of negative 8, 8 square root of negative 1. And again here, just multiply the first terms and the last terms. This gives us x squared minus 8 times negative 1. Okay. That's not 8, that's 64. Sorry, 64. Equals sorry, equals, sorry, x squared plus 64. Excuse me. That's the answer. Okay, let's go to the last example here. So, again, we have a 2i there, so I will replace that I by square root of negative 1. Okay, so this gives us x equals negative 5 plus 2 square root of negative 1 over 3. And then the other one is negative 5 minus 2 square root of negative 1 all over 3. Okay, so let's use the multiplication property of equality, or just bring that 3 to x. That becomes the numerical coefficient of x. This is 3x equals negative 5 minus 2 square root of negative 1. Okay, and then convert this into a binomial. So this will be plus 5, that's negative 5, right? So you put plus 5, and then enclose that into a parenthesis, minus 2 square root of negative 1. The other is the same as that one, right? The difference though is this minus sign, this will be plus here, 2 square root of negative 1. Okay, equals 3x plus 5 times 3x plus 5 minus 4. Okay, apply that here, and this minus 4 times negative 1 equals 9x squared, right? Plus 15x plus 15x. This is plus 25 plus 4. Okay. Finally, combine this and that one. This gives us 9x squared plus 30x plus 29. Whew, there you go. So those are the 10 examples that I have for you and I prepared for you on how to create the quadratic equation given the roots. So this is just one of the two ways of I know how to do this. Please watch also the other one. The other one is almost the same as this, but we will be using a formula there. Okay, so please watch that video and don't forget to subscribe to my YouTube channel. Thank you.